So I'm going to continue today with the lesson that we left off with on Friday, which is the sine law. We're going to continue doing examples of the sine law, but we're going to deal more specifically with something called the ambiguous case. Now, when you hear the word ambiguous case, this is a real pain in the butt. And part of the reason I'm writing this down is because of it being a pain in the butt, there's a special way you can remember these triangles. So what's going to happen is in the ambiguous case, when you're given the value of two angles and one side, there's no problem. There's a uniquely defined solution and the sine law will give you one answer. However, when I have a triangle that has two sides and an angle, and more specifically, we call this triangle the ass triangle, it should remind you that this is going to be a pain in the butt, okay? It's the ambiguous case potentially happening, and we're going to go through in the lesson about when this ambiguous case will occur. But when you see a triangle that is this ass triangle, just remember it's going to be a pain in your butt, okay? Now, what we need to look for is there's three possible outcomes when you have a triangle of this sort. The first thing is that if you have a side and an angle, you could have a situation where there's no triangle that's going to be possible. So sometimes we draw these triangles out, we put the numbers on the triangles, but if we were actually going to measure using a ruler and a protractor with the angles and the sides they give you, the triangle doesn't actually happen and it doesn't actually draw out, okay? You could have no solution or no triangle possible. You can have one triangle possible, or you can have two triangles possible, and the two triangles are giving you two different answers. And step number 3 here is considered the ambiguous case. So what we're trying to say is if we have the triangle that's your ass triangle, or you can think of it as side-side angle, which doesn't help me remember this. When you have this ass triangle, what you want to remember is there's a situation where there's going to be possibility of more than one solution. And so what we need to do is in given questions, they're going to ask you, here's the triangle, solve the triangle, and you're going to have to know, is there one solution, two solutions, or no solutions? So we're going to go through this in steps, okay? So we consider a triangle where we're given the angle A, and I'm going to always line up my triangle where the angle A is always sitting on the bottom left of the diagram. For whatever reason, I have trouble manipulating triangles around and rotating them in my head. So you'll always notice when I'm given a triangle where there's an angle side happening, I will always put the angle at the bottom left. Okay, it will help me remember the scenarios that happen with the ambiguous case. So I'm very visual, and putting it at the bottom left helps me remember the steps involved in actually going through the steps for the ambiguous case. Now, this angle A that they give you could be acute, which means less than 90 degrees, or it can be obtuse, which means between 90 and 180 degrees, okay? So this would be angle A that's acute, and this would be angle A, where angle A is obtuse, okay? Now you'll notice in both scenarios, we have the same exact triangle. This length B is going to be the same in both scenarios, and the length AB is going to be the same in both scenarios. What is going to differ in both scenarios is the length CB. These ones are going to be different. Okay, but the other two will be the same. Okay, and then of course, the angles themselves will be different. Okay. Now, if I want to find the height of both of these triangles, in both of these triangles, this h defines the height of the triangle. So over on the left triangle, the height is clearly from the vertex of the triangle to the base. On this triangle, the height of the triangle is considered from that vertex to the base. So they're both considered the same height of the triangle. So in order to find this height of the triangle, I'm going to look at the acute triangle in this example. I'm just going to pull this out, and I'm going to pull this triangle out, or if you can want to, you can picture pulling this triangle out. You're going to notice that this triangle has a 90-degree angle, so we can use all of our SOHCAHTOA and all of our a squared plus b squared equals c squared Pythagorean theorem rules. Okay. Now, this is the height of my triangle in both scenarios. I'm going to say that in my triangles, I'm going to focus on, sorry, it's not going to be this triangle. It's going to be the triangle that has the theta in it. So I'm going to kind of rotate this triangle around. My apologies. Let's rotate this triangle around. So this is my height. Now I wanted to rotate the triangle around because this theta is the one that's given to me. So I want to make sure that when I'm doing the height of the triangle, I'm using the theta that's given to me. Now this side is labeled my opposite, my adjacent, and my hypotenuse. So in my triangle, I'm given the theta. I want my opposite in there because that's where the h is. And I want the hypotenuse in there because my hypotenuse, this b value in the triangle, would be given. Okay, so I'm going to label my hypotenuse b, and b is given in my triangle. So then if I want to solve for the height, I'm involving the opposite and the hypotenuse, which is my part of my SOHCAHTOA. Sine of theta is equal to opposite over hypotenuse, h over b. The theta is given and the b is given, so I'm really solving for h. So I'm going to multiply both sides by b. So h is equal to b sine theta. Okay, this is a super important relationship to know because this is going to help us determine whether the ambiguous case is going to occur or not occur. It's going to be all based on this value of h. Okay, so this is your key, one of the super keys to help you determine the ambiguous case. Now, when I have angle A being obtuse, so that second triangle on the right-hand side, you got to remember we're given this side and we're given this angle. Okay. One of three scenarios could happen. Okay. Now the A, the little a here, one scenario could be that this length A is smaller than length B. So if length A is smaller than length B, it means that this can't even form a triangle at all. Okay? So if A is less than B, we get no solution. Okay? Because it doesn't even close and the triangle's not even formed. If A is equal to B, we also get no solution because, again, the triangle is not formed. Excuse me. Now, if A is greater than B, here's my length of B, which was given. A being greater than B means that this triangle is actually going to form. And if A is greater than B, then we get only one solution. So what we're trying to say here is that if the angle they give us, if theta is obtuse, and you have an ass triangle, there is no ambiguous case. The ambiguous case is being formed if I'm getting two possible solutions, and in this case, there is no two possible solutions. Okay? So again, we're only going to consider when we're given an ass triangle, angle, side, side in a sort of a consecutive order or an adjacent order. We need to figure out whether there's two triangles formed, but in the obtuse example, we have no ambiguous case. Now, when my angle A is acute, so remember, we have they would give us an angle. So here's my angle. Here's my side, B. This is angle A. And then based on the number A they give us, this A, now I'm closing that triangle off, but we don't actually know if this triangle closes off or not. So the other side they give us is side A, and we have to decide what side A is going to do in relation to the triangle that's sort of already on the left-hand side. So I'm going to put this information in my diagram. You're going to notice on my ass triangle, the A will always be on the left, bottom left, because that's where I'll position it. Here's one of the sides that are given. Angle A, and the side opposite to it is little a. This little a would be given to us, and then based on some dimensions, I'm going to know how this angle A closes off this triangle. Okay? Now, what we want to do is we want to take that H ratio, which is the height of the triangle, and I want to determine how side A compares to this height of the triangle. So if you remember, we scroll back up, we calculated the height of the triangle using my SOHCAHTOA, and we got a relationship of B sine theta is equal to my height of my triangle. So this, again, is super key to remember. We're going to take that. We're going to look at our H. Now, if angle A is less than this height of the triangle, so this angle, here's the height of my triangle, but if angle A, my side A is shorter than that height, then we don't even get a triangle being formed. So if A is less than if angle A is less than H, and I keep saying angle, if side A is less than H, we get no solution. Because what's going to happen is this little piece is shorter than making a 90-degree triangle, so we're not even going to get a triangle being formed. If side A, I got to get that out of my head, if side A is equal to my height, then I'm getting a 90-degree triangle. I can use all my SOHCAHTOA, so I'm going to say if A is equal to H, we get a right angle triangle formed. And you get one solution. You get the solution that you're going to make by looking at this triangle. So you draw this triangle out, and then you would go ahead and solve this triangle. And when I mean solve it, I mean find all the missing sides and all the missing angles. And what you have at your disposal is your SOHCAHTOA rules. Okay? So your sine is opposite over hypotenuse. Your cosine is adjacent over hypotenuse. Your tan is opposite over adjacent. And you're allowed to use your a squared plus b squared equals c squared, where c is the hypotenuse. You're allowed to use that the angles in a triangle add up to 180. So you have lots of things you can use. That was that whole first half of trig that we covered. Okay, so that will be that scenario. Now, most often, if I'm giving you an ass triangle, which is the one that's a pain in your butt, most likely, in the textbook there might be problems, but if I'm giving you something that doesn't have a 90-degree angle, I'm probably going to give you the scenario where it's still not going to be a 90-degree angle. But if it happens to be like this diagram, then it'd probably be me giving you just a problem that's in the first half of trig. And I don't want this to connect with the first half of trig because I want to deal with the second half of trig. But just know that this right angle triangle is possible. Now, if this is my angle, here's my angle A, my side, that's my ass triangle. if my angle A is greater than or equal to B, then this A will swing down over here and give you a triangle. And we only have one possible solution. I just swing that side down and I get one possible solution. So A is greater than or equal to B, we get one solution. Okay, now if my angle, and this is the one that's forming the ambiguous case, so if I calculate this height and this angle or this side A is bigger than this height but smaller than this side, then this side A can swing into two positions. It can swing into this position in red where it's this length, or it can swing into this position in green where this is my side A. Now this angle or this side in green is sort of swung a little bit too far. So this would be that other side A, and we would just sort of get rid of this little piece that's right here. So there's my situation that's happening. This A could be the red A, which is just, it's greater than the height but smaller than the other side. Or this side A could be over here and I'm forming a triangle. This is A, and this is my side A forming my triangle. So I want to show you the two triangles that are formed. One of them is just take the full triangle that's kind of shown. Here's my angle A. Here's my side opposite. Here's my side B. And then there's the theta that was given. That's one triangle possible, and that's sort of my outer triangle. My inner triangle that's possible, I'm going to highlight it in yellow. It's always a little bit trickier to draw, and I'm going to draw this triangle out. Okay, and then this is this would be my angle A that's given. But what's going to differ is this angle B is going to be, I'm just going to call it theta B. My theta B is going to give me two different answers depending on which triangle I came from. This side A is the same and this side B is given. So just remember, here's my ass triangle, angle, side, side. That's the only information was given to me. I get two possible answers when I solve this triangle. Okay, this theta B is going to look different than theta B here, but the bottom is going to also be different here. So if I draw this length, this side and this side are going to be different, and this angle is going to be different as well. Okay, but this is the scenario that's giving me two possible triangles. So if H is less than A, or H is greater than A in this case, let me write this down and then I'll talk about it. So my side A is greater than my side H, but smaller than my side B. We get two solutions. Okay, and my two solutions are exactly what I've shown here. Now, in order to find your solutions, you're going to use all your sine law, and you're going to find the solutions using whatever we've learned in sine law. Okay, we're also going to learn cosine law, which will apply to these triangles. And then basically, we get two triangles and we show the information for both the triangles because they would both form the solutions. Okay, this page is your summary page. This is kind of the key for this. Now, when we do sine law and cosine law, there's kind of two big ideas formed. We've talked about sine law on Friday. All those rules apply. We're going to talk about cosine law on Tuesday. And then there's something kind of minor in here called the ambiguous case. You will know that it's the ambiguous case because it will be a pain in your butt. And the specific kind of triangle you're going to get is the ass triangle. And then you have to just remember when you have this very specific ass triangle, there could be more happening. Now, if I'm going to give you ambiguous case in a test, this is already going to be up in the proficient and exemplary range. So again, I'm not going to ask a whole test with ambiguous case happening because it's a very challenging idea for students, and it's going to be saved for those proficient exemplary problems. So if you understand everything in the outcome except have a little bit of trouble with the ambiguous case, you're probably not going to get into that upper proficient exemplary range. Okay, summary of the ambiguous case. You are going to get the ass triangle. So what's going to be given in a question is you're going to have an angle, a side, and a side completely right beside one another, okay? If my angle is obtuse, which means between 190 and 180, if A is less than or equal to B, you have no solution. If A is greater than B, you have one solution. If my angle is acute, everything is based on that H value we calculate, and the H value is equal to B times sine of A. Okay, and those four scenarios are being formed. Okay, so what we want to do is we want to kind of make ourselves a little kind of flow chart here, mini flow chart with steps. So we're going to be given our ass triangle. You're going to notice it and you're going to be like, oh crap, this is going to be a pain in my butt. You have to think about it. Okay, you look, is the angle that's given, the angle A, is it acute? Which means less than 90. If it's less than 90 and you calculate the H and the side A is between the side H and the side B in terms of its length, you have two triangles. Okay? Other than that, you can kind of solve the problem your typical way, and you should be getting sort of the solution based on what the data is showing you. This is the scenario that's going to cause you problems. This is what you have to watch out for. So let's go ahead and actually look at what's given to us. So let's pretend this is a given question. I'm going to draw this triangle out, just kind of whatever I know. Okay, so I'm going to put angle R here. This angle that's given to me is 30 degrees. I'm going to put side R on my triangle, which is the side opposite to the angle. This is 24 centimeters. And I'm going to draw my side S. I'm going to put S here, and I'm going to draw my side opposite to it, 42 centimeters. Okay, I look at this triangle and I'm like, oh crap, I don't like what I'm seeing. I'm given an angle, side, side triangle. Now I've intentionally drawn this triangle in the orientation that I want, which is my angle that's given to be at the bottom right. But you could have switched the numbers around. You still want to look, is it an angle, a side, and a side right adjacent to one another? This is the ass triangle that's being drawn out. So you look and you're like, oh crap, this is an ass triangle. So what we want to do is we want to say, yes, we have an ass triangle being formed. We want to ask ourselves, is the angle kind of to the bottom right, is the angle given, I'm just going to write angle given, which would be my A sort of thing, is that acute? This is a problem because now that it's acute, I could have ambiguous case possible. My third step is to calculate my H, and my H is going to be my B sine A. Now in this case, we want to be careful because our letters are a little bit different. So I'm going to put some letters kind of in blue. This is sort of my angle A, my side A. This is like my B, and this is like my side B. Okay, if it helps. I'm going to calculate B sine A, which is the 42 sine of 30 degrees. And I'm going to calculate this value. So you put 42 times sine 30 in your calculator. Make sure your calculator is in degree mode. And I get this to be 21 centimeters. Okay? So now what I want to do is I want to look. H is 21 centimeters. I want to put my A over here. My A is 24 centimeters, so this is bigger. And then I also see my B This is sort of what I'm looking for. Is this happening? Because if this thing in yellow is happening, then I have the ambiguous case with 2 triangles possible. And then my B is 42 centimeters. So because I have an ass triangle, my given angle is acute, and I satisfy this inequality, if you want to put it, I have 2 answers possible. So what we're going to do is we're going to draw the 2 possibilities, okay? So when I draw the 2 possibilities, here's my height h, okay? So I'm going to draw the triangle that I've already drawn out. That's going to be my one triangle. Here's R, S, T. This is going to be 30, 42 centimeters, 24 centimeters. And there's my first triangle. My other triangle is taking this piece and swinging it to this side. So I'm going to draw the other triangle out, which will be this triangle in yellow, drawn in. And so this will be my 30 degrees. The letters don't change on my triangle, but the picture changes. This will be the 24 centimeters. This will be the 42 centimeters. So there's my 2 triangles, and I want to solve these 2 triangles. Okay, so I'm just going to pull this. I don't know if it's going to let me, it's not going to let me pull it up. But here's the scenario where I have, actually what I'll do is I'll move this down. So I'm going to pull this triangle to my scenario that has my obtuse triangle, which I'll put it down here. And then what we're going to do is solve these as 2 different scenarios, okay? So what we want to do is we want to do the acute scenario first. So when they say to solve the triangle, I have to find all the missing angles and all the missing sides. So we're going to write our sine law down. Sine A over little a equals sine B over little b equals sine C over little c. Or if you prefer, you can write it the other way around, okay? It doesn't matter. When you see the relationship on the formula sheet, both are identical in the sense of calculations. So for whatever reason, when I think of sine law, I automatically am like, oh, I'll start with sine on the top because it's just what I remember, okay? This is where we want to highlight our pairs. 1 pair, 2 pairs, 3 pairs. Now you can see that information in red is completely not given to me at all. So I'm going to start with my information. Sine 30, sine of an angle over its opposite side. Sine of an angle, which I don't know S, but I have its opposite side, which is 42. I'm going to go ahead and solve for sine S. So what we're going to do is I'm going to multiply both sides by 42. So 42 times sine 30 over 24. And then I want to solve for S, which means I have to get rid of, I'm actually going to get rid of that color. I'm going to do it in orange. So I want to solve for S. So I need to undo the word sine, which means I'm going to do the inverse sine. I'm going to take away that sine in sort of a general sense. And I'm going to write sine 30 over 24. And I work this number out on my calculator. So I'm going to go sine inverse, shift sine, and then type this in very carefully. Watch your bracketing. And I'm going to get that this is a 61-degree angle. So I'm going to go ahead and put that in my diagram because now I've calculated that value out. Now I need to solve the red stuff, the angle T and the side T. Now the angle T is super easy to solve because now, because I was able to solve angle S, I have angle R and I can use the triangles, the angles in a triangle add up to 180 degrees. So 30 degrees plus 61 degrees is 91 degrees. And my total angles in a triangle add up to 180. So if I go 180 minus 91, I get 89 degrees. So that top piece is 89 degrees. Now I'm ready to use the sine law relationship again. I'm going to use the yellow relationship because that was already information that was given to me. So sine 30 over 24 equals sine of 89 over t, little t, which is the side I'm looking for. Now again, some of you find it a little bit weird that the t is on the bottom, so I can switch and do the reciprocal of both sides. Only on this type of example where I have a single fraction on each side. So I'm going to isolate for t by multiplying both sides by sine 89. So sine 89 times 24 over sine 30. And then you can see I've already got t isolated. So my t, you're going to carefully put that into your calculator. And you're going to get 48. And it says round answers to the nearest tenth. So I'm going to round my angles to the nearest whole number and my side lengths to the nearest tenth. Just right now, just because that's what my answer key has, but you would want to round this one to the nearest tenth. Let me actually do that. It's not a big deal. 42 times sine 30 divide by 24. You get 61.0 degrees. So you want to make sure you round that to the nearest tenth. 89 rounded to the nearest tenth is 89.0 degrees. And then my t is 48.0 centimeters when I work that out. And I'm just going to double check that calculation on my calculator here. I get 47.99, which rounds to 48.0. Now, when you're solving the second scenario, which is that other solution, what you want to remember is that to find angle S is going to be your starting point. Now, what we do is we sort of put a horizontal line here. In the question above, we solved this angle to be 61 degrees. So what we want to do is to find angle S, you would do your sine law, but what's going to happen is your sine law is going to give you the same calculation as it just gave us in the step above. Sine of 30 over 24 equals sine of S over 42. I'm going to color it the same way as I did before. Here's my angle and my side in orange, the angle given and its opposite side in yellow, and the angle T in red. Okay. Now the problem is when you solve for S from here, you're going to get the 61.0 that we solved above, but then this is a problem because we know that this is a different triangle. So to find the angle we want, we think of angle S as a reference angle, and then to get the rotational angle, I'm going to go 180 minus sort of this reference angle to get this piece that's left over, which is 180 minus 61, which is 119 degrees. So if you're solving the obtuse triangle and you try to use the sine law, you're going to get the same answer as we did in the step above. So this angle here is always your first step. And you take the answer you got from the acute triangle, you take it away from 180, which is the same step you're always going to do. That's going to give us 119 degrees. Now I'm ready to do my angle T. So 119 plus 30 is 149 degrees. I know that the total angles in the triangle add up to 180 degrees. I'm going to subtract off 149 degrees, and I get this angle to be 31 degrees. And then again, I can use sine law to set up my other missing side using what I had before. So I'm going to use the yellow stuff, that yellow pairing, because that was the initial information given to me. And then I get sine of 31 divided by my missing side, which I'm going to call T because this was called capital T. Now again, some of you don't like that the 24 is on the denominator, or sorry, the T is on the denominator. So what I'm going to do is I'm going to flip both sides, and when I say flip, I mean like switch the denominator and numerator on both sides. Sine 30 equals T over sine 31. And then I'm going to multiply both sides by sine 31. And this will give me t. So you're going to carefully put that into your calculator, and you're going to get that t is 24.7 centimeters long. Now again, it's really tricky to notice the ambiguous case. You just think in your head, ambiguous case is a pain in my butt, and you find which triangles are the asked triangles. So you can draw them however you want given the information. When you're done drawing them, just check. Do you have an angle starting at the bottom? You kind of go to the side that's right adjacent to it. You're going to see a number and then another number right to the side that's adjacent to that. And then you start to think, okay, I have an asked triangle. This is going to cause me problems. If you have any other triangle where it's not an asked triangle, it's not going to cause you problems, and you just proceed as normal with your sine law like we did on Friday. You highlight the pairings, and then you just sub it into your formula, and you go at it, okay? Now, what you want to do is go on D2L, go to the textbook pages that are in D2L, and try to do some of these examples in here to help you recognize ambiguous case. When we give you ambiguous case on a test, it'll be really subtle. We'll just give you questions and we'll say solve, solve, solve. And if you don't even notice on that entire test there's ambiguous case, well, you didn't notice it, and you'll probably peak out at the highest mark possible to be like maybe a P1 or a P2 depending on the test. But again, it'll be really subtle. You'll have to recognize that the triangle drawn out or the triangle information given to you is kind of like an asked triangle, and then you start to proceed with the lesson that we just learned. Okay, I will post some more practice on ambiguous case in the D2L shell, and we'll continue with